Roller coaster questions, in theory, it's the same physics at the top of the hill as it was at the bottom of the hill. At the bottom of the hill, people feel a little bit heavier. There's a potential it could break. At the top of the hill, it should be the same physics, but as you'll see, the top of the hill can get a little bit confusing sometimes. I'm going to kind of talk you through, we'll get the same physics, but I'm going to talk you through the roller coaster question kind of twice. When I typed it, originally what I was picturing when I typed it was this. We got a hill that happens to be circular, and we've got the roller coaster cart riding on top of the hill. In a situation like that, well, in every situation, gravity is going to be straight down, but especially when the cart's riding on top of the hill, the normal force is going to be upward. This is comparable to someone standing in an elevator as the elevator accelerates downward. The downward force has to be bigger. We can't change gravity, so normal shrinks to compensate so that it can accelerate down. Since the normal shrinking, you feel lighter than usual. At the bottom of the hill, the normal had to be big, so you feel heavier than usual. At the top of the hill, the normal shrinks, so you feel lighter than usual. The way this question's set up is the rider feels weightless. So imagine we've got a roller coaster going over the top of this circular hill. If it goes kind of slow, then the free body diagram would look like what I've got there. Normal force upward, gravity downward. At that moment when they're at the top, they're accelerating downward, so the normal would be smaller than gravity, so that there's that unbalance to allow it to accelerate down. As the car goes faster and faster, we need a bigger and bigger unbalance. We need gravity to be more and more overpowering to the normal force. So as the roller coaster cart goes faster and faster, the normal force will get smaller and smaller. But there's a limit to how small the normal force can get. Well, kind of. If you feel weightless, really what that means is that the normal force has dropped to 0. So when we set up F net equals ma, I would have said Fg minus normal force equals 0, but the normal force is 0, so it's just Fg equals ma. And the a is going to turn into v squared over r. M's are going to cancel out. This one, you were asked for the v, so this turns into v squared equals rg. The r that I made up was 16, g of 9.8. After square rooting, we're going to get 12.5. Oops, a little bit messy down there. So for a roller coaster with a radius of 16, if you go over the top at 12.5, you're going to feel weightless. Now, where I cut myself off is, what if you go faster than 12.5? Well, if there's no safety measures, if you're going faster than 12.5, your body's going to want to follow a bigger radius. Kind of like a car without enough friction. The car would slide to the outside. If there's not enough gravity for the circle you're trying to do, when the normal drops to 0, if you go even faster, unless we can add a downward force, you're not going to follow that circle. You're going to follow a parabola and become a projectile. Normally, so I'm going to just say if faster, normally a roller coaster has safeties built into it. Otherwise, insurance companies would never let them run. So next time you're at a place with roller coasters, if you look, there's a little set of wheels underneath the track. What that allows is if the car's going faster than that threshold speed, the normal force can be downward to help gravity. So they would both be downward. The car isn't allowed to fly in the air, and when you ride on the roller coaster, it's going to be hard for me to draw it, there's like a safety harness, like a shoulder strap over top of your shoulder to add a downward force if need be to keep you from flying out of the roller coaster. That's the scenario if you ride on the outside of the curve. The physics is a little bit different if you ride on the inside. So still a vertical circle, still at the top, but what if you're hanging upside down? Then the issue isn't if you go too fast. If you're going really, really fast, gravity's downward. If you're going really fast, the normal force is also downward to help you go in your circle. But as you start to slow down, the normal force gets smaller and smaller and smaller until it eventually drops to 0. That would be the weightless case. If the radius stayed the same, you would still feel weightless at 12.5. It would feel different because you're upside down, but you would still feel weightless at the speed of 12.5 for the 16-meter roller coaster. But if you're on the inside, if you go too slow, the danger is gravity is going to be too strong. And gravity is going to pull you down inside the radius of the circle. So the danger is if you go too slow, gravity's too big, you're going to fall into the middle of the circle. Again, insurance companies don't like that. So in roller coasters, those wheels on the outside of the track, they would keep you from falling in. They would put an upward force this way so that the overall net force is a bit smaller. They have to fight gravity because gravity's too strong. So we'll have to be careful when it's a question about the top of a vertical circle. We'll have to think about whether it's on the outside of the circle, in which case you will feel weightless. And if you go too fast, the danger might be you fly and get airborne. Or if it's a question at the top of a vertical circle and the object is on the inside of the circle, then the danger is if you're going too slow, maybe you'll fall into the middle of the circle. To prevent that, the normal force would have to be upward. So in a way, it's the same physics. We just have to be a little bit careful at the top to think about the setup. Are you on the inside or the outside? Is the danger that you could go too fast?